Hi folks, today we're going to go over the 35s. You're going to find yourself doing a lot of pausing of the video to write stuff down. There's not enough time in a 15-minute video for me to pause to let you write things down. So every once in a while, pause the video, write what you need to do down, try the problems yourself. That's the best way to learn. So the first thing we're going to do is state Le Chatelier's principle. So if a chemical system at equilibrium experiences a stress, the reaction will shift to lessen the effect of the stress. And this is known as Le Chatelier's principle. And that you should write on your cover if you've not already written on your cover. If you add an aqueous or gaseous substance to a chemical system, the system will shift to remove it. If you remove an aqueous or gaseous substance from a chemical system, the system will shift to replace it. Again, make sure you're pausing the video to write these items down. There is no way you should be doing it at the same speed that I am going through it. In a demonstration involving a reddish-orange complex called iron thiocyanate, equilibrium reaction is as follows. So these two items are colorless, and when they combine together, you get a red color. Number 4, it says, note, the dissociation of iron 3 nitrate is this right here. It says that the nitrate ion is a spectator ion. That means nitrate right here is not involved in this chemical reaction at all, so it simply does nothing. So if I'm going to add iron 3 nitrate to this chemical system, it's a fancy way of saying adding only iron 3 ions. So it's a fancy way of saying adding iron 3 ions. So again, this is a wordy way of saying adding iron 3 ions to the beaker. And these types of problems are just slightly more difficult than what we've been giving you so far. So we're stretching your thoughts. So 4A, which way will the reaction shift if iron 3 nitrate is added to the beaker? Again, this is a fancy way of saying iron 3 ions. Pause the video, see if you can get this correct. Well, if I am adding some iron 3 ions to it, that is the stress, the reaction should shift to try to get rid of those iron 3 ions. The only way you can get rid of those iron 3 ions is to react these two things together to make this right here. So it would shift towards the products. What color would it be? Well, if we are shifting towards the products, we are shifting towards red, so it would be more red. So this is the actual experiment. So right here is the color that it would be at equilibrium. What did you observe when you added some iron 3 nitrate to the system? So what did it actually look like if you did this experiment? And it would become a darker red. What is a good, complete explanation for what happened? The extra iron 3 ions reacted with the thiocyanate ions to produce more red iron 3 thiocyanate. Again, pause the video so you can take your notes. So write the dissociation for potassium thiocyanate. Try this. You would end up getting potassium ions, aqueous, and you would end up getting thiocyanate ions, aqueous. Potassium is going to be a spectator ion in this particular reaction that we're going to do on the next slide. So which way will the reaction shift as potassium thiocyanate is added to the beaker? So here's our beaker with everything in it. We're going to sprinkle in some potassium thiocyanate. What will actually happen? Go ahead and take a guess at it. Well, if we're adding some more potassium thiocyanate, as soon as it gets into the beaker, we're going to end up having more of this available. So the stress is SCN is going up. So the reaction should shift to get rid of that SCN. To get rid of it, we have to produce more of this chemical. So this reaction is going to have this plus this react, and we're going to make more of this FeSCN2 positive. So it would shift to the right. What color would it produce? Well, if we are shifting this direction, we are shifting towards red, so it should be more red. So let's take a look at the actual experiment. This is the color at equilibrium. We add some potassium thiocyanate to it. It did in fact become darker red. What's a good explanation for that? The extra thiocyanate ions reacted with the iron 3 ions in the solution to produce the red iron 3 thiocyanate. Again, pause the video so you can take notes. So, question 6. In question 4D, you may have said that there was leftover thiocyanate ions that reacted with the extra iron ions that were added. Question 5D, you may have said that there was some leftover iron ions and it reacted with the thiocyanate that were there. Well, if there's leftover iron ions and leftover thiocyanate ions, why don't they react together to become the iron 3 thiocyanate? And the answer is, they do. So, these two, if they're around, they react together to make this compound. But every time this reaction happens this way, we have some of this that breaks down back into the ions. So every time these two combine, one of these breaks apart. That's what's called equilibrium. So sodium phosphate is added to this reaction. So again, we got a beaker. We're going to sprinkle in some sodium phosphate, and we want to know what's going to happen. It says phosphate removes iron. So this is a fancy way of saying we are removing iron ions. It removes those iron ions because it forms a solid precipitate with the phosphate. So which way will the reaction shift? Take a guess. What color will it be? Take a guess. Pause the video. Well, which way will the reaction shift? If we are removing iron ions, that's our stress, the reaction should shift to try to produce iron ions. And to produce iron ions, you would shift towards the reactants. So we would end up making more of this, and we'd end up getting some of this. What color will it be? Well, we're shifting this direction towards the reactants, and the reactants are colorless, so we would expect more colorless. So here is the color at equilibrium. We add some sodium phosphate to it, and lo and behold, the color actually goes away. What's a good explanation for that? The phosphate removes the iron ions, so the reaction shifts to produce more iron ions, and those are colorless. So in other words, this breaks apart and it's red in color, and we produce this which is colorless, and we produce this which is colorless, so the whole thing becomes colorless. For this next reaction, we're on the back side. This is a light blue color, this is colorless, and this is a dark blue color. This is the color at equilibrium. The first thing it wants us to do is write the dissociation reaction for copper 2 sulfate. Try that. Pause the video. Cu2 positive aqueous, SO4 2 minus aqueous. That is the dissociation reaction. Which way will equilibrium shift if some copper sulfate is added to it? So again, this is our beaker right here. We're sprinkling in some copper sulfate. As soon as it hits the liquid, this is what's going to break apart. We're going to have that floating around inside the beaker. Sulfate is not involved at all in the chemical reaction, so it's a spectator ion. So this is a fancy way of saying, hey, we're adding some copper-2 ions. If copper-2 ions are added to it, they are going up. That is a stress, and it's going to react to get rid of those copper-2 ions. The only way we can get rid of copper-2 ions is to react with these ammonia and to produce this complex, this copper-ammonia complex. So it would shift to the right, and what color would it become? It would become darker in color. Some HCl is added to this beaker. So again, here's our beaker. We're adding some HCl to this beaker. It says the HCl reacts with ammonia and removes the ammonia from the solution. So in other words, we're taking the ammonia out. Well, if we take out the ammonia, which way will it shift and what color will it be? Pause the video, give that a shot. If we remove the ammonia, it's going to shift to produce more ammonia, so it's going to shift to the left. If it shifts to the left, it's going to become light blue and colorless, so it's going to become lighter in color. Which way will equilibrium shift if more ammonia is added? So again, we have our beaker. We're going to add some ammonia to it. What color will it be? Well, if we add ammonia, that's the stress. It's going to want to get rid of the stress. So the ammonia is going to react with the copper-2 ions, and it's going to produce this complex. So we'll shift to the right, and it will become darker in color. Hydroxide precipitates out the copper-2 ions. Which way will the reaction shift? See if you can figure this out on your own. Pause the video. So again, we're going to add some hydroxide ions to it. It's going to take this out of our solution. So that is the stress. The reaction is going to try to replace the copper ions that we just removed. So the reaction will shift that way towards the reactants. The reactants are lighter in color, so they will become lighter in color. The rest is homework, and there is another page. So there is a front and the back to the first page, and then there's a front to the second page. It's a whole big table. Make sure you don't forget to do that problem. Hope that helps. Please come in for help if you need it. And please go back in the video and pause the video and try the problems yourself and see if you can get the concepts.